Assalamualaikum to conference panel, conference committee, and all participants. Today, I would like to present my paper ID 162, minimizing butadiene level in liquefied petroleum gas via non-spirit blending by numerical approach. LPG is liquefied petroleum gas have variable commercial rates depend on the various composition. LPG properties depend on the composition was propane and butane were major components. LPG composition varying based on the sources of each production, whether from extract from refinery streams or from natural gas. Composition of propane and butane in LPG mix play important role on the properties of products, which effect on the vapor pressure and density of the LPG product. LPG product with more than 0.1% of butadiene was classified as carcinogenic. That's why the limit was set to below 0.5% of weight fraction. This carcinogenic effect may cause cancer and genetic defects by inhalation. Here is safety data sheet of the LPG state that the butadiene level should be below 0.5% of weight fraction. The LPG plant operator facing the problem in recent years where the imported LPG composition from the outside sources contain the level of butadiene exceed the limit of 0.5% of weight fraction. LPG composition which have butadiene level exceed than 0.5% would be considered as off-spec product. When the LPG products contain butadiene level below the 0.5% of weight fraction is considered as on-spec product. To reduce the contents of the butadiene level with exceed of 0.5% weight fraction in off-spec LPG product, blending on-spec LPG with the off-spec products was introduced. Methodology mass balance for LPG mixing ratio was performed to find required LPG on-spec products to mix with 5 samples of off-spec products. Table 1 shows that the components propane, butane, and butadiene in LPG. On-spec LPG composition was fixed. Off-spec LPG was various from sample 1 to sample 5. The simulation of on-spec LPG into the mixing of off-spec LPG inside mixer tanks was conducted with the dimension shows that in table 2 by NCS 2021. The figure 1 shows that the mixer tank dimension which has the diameter of 330 mm, height is 504, and capacity of 15 kg. At the initial stage of spec LPG product was already filled in mixer tank. After that, the on-spec LPG composition, the on-spec LPG will be filled into the mixer tank to mix and blending with the off-spec product. Simulation was conducted by Fluent, which is one of the safety software for blending off-spec LPG sample number 1 with required on-spec LPG anti-butadiene weight fraction below 0.5% of weight fraction. The blending procedure repeated for the sample number 2, sample number 3, sample number 4, and sample number 5. Homogeneous blending time was recorded by monitoring the normalized concentration at the bottom of the mixer tank in Fluent simulation. Figure 3 shows that the mesh model of the mixer tank. Figure 4 shows that the pressure monitor point to monitor the normalized concentration during simulation. The jet mixing approach is selected to predict the homogeneous blending time for each different ratio of blending. The mixing time correlation selected was Len and Rice 1981, Mariama Ben Masusina 1982, Greenville Filton 1997, Hebe and Monigal 1978. Table 5 shows that the correlation that was been selected. This correlation will use to calculate the predicted homogeneous blending time, and the result will be compared to the simulation result. Result in table 6 show that the number of samples from 1 until 5 on spec LPG required is increased once the butadiene fraction is increased in the off-spec composition. Figure 5 shows that the required weight of on-spec LPG to minimize the butadiene level down to 0.5% of spec fraction. Figure 6 shows that the initial stage before the blending. A represents sample 1, B represents sample 2, C is represents sample 3, D is represent sample 4, and E is represent sample number 5. Figure 7 shows that on-spec LPG filling into mixer tank and contact with the off-spec LPG. The flow time is decreasing from sample number 1 until number 5. Figure 8 shows that 95% of mixing recorded by tracer at center bottom of the mixer tank. The flow time was decreased from sample number 1 until number 5. Figure 9 shows that 99% of mixing recorded by tracer at center bottom of the mixer tanks. The flow time was decreased from sample number 1 until number 5. The result of the homogeneous blending time was shown in table 7 for sample 1 until sample 5. Figure 10 shows that the comparison of homogeneous blending time of empirical correlation with simulation results. Based on the result, Mariama-Ben-Magusina correlation predict the homogeneous blending time 5 times longer than simulation 99% of mixing and 10 times compared to 95% of mixing. Then and Rice correlation predicts the homogeneous blending time with 2 times longer than simulation result of 99% of mixing and 4 times longer to 95% of mixing. Review-Titan correlation, review-alternative correlation result so that similar to the Lane-Rice, which was 2 times longer than simulation result of 99% of mixing and 4 times longer to 95% of mixing. TBM molecular correlations shows that the result 4% of deviation compared to simulation result of 99% of mixing and 2 times longer compared to simulation result of 95% of mixing. Result prove that the increasing of on-spec LPG will reduce the homogeneous mixing time, which was increasing in the blending ratio from sample number 1 to sample number 5. The homogeneous blending time decreasing when the quantity of on-spec LPG required, which contain less butadiene, increasing from sample number 1 to sample number 5. Project mixer experimental correlation produced different result in prediction of homogeneous mixing time compared to simulation on 95% and 99% of the mixing. Each jet mixing correlation was developed by different measurement technique and monitoring method of mixing time in jet mixing tanks. As conclusion, the on-spec LPG required to minimize the percentage of weight fraction of 0.5% was increased when the level of butadiene increased in off-spec LPG. The homogeneous blending time recorded by simulation shows that the decreasing since the quantity of on-spec LPG blended with off-spec LPG increase. This fact proves that the increase of butadiene contents in off-spec LPG products will require the more quantity of on-spec LPG to reduce the butadiene contents, but the homogeneous blending time was decreased. The homogeneous blending time predicted by selected 4 empirical correlation will make agreement with simulation that the homogeneous blending time decreasing once the quantity of on-spec LPG to be blended was increased. 4 empirical correlation result different of homogeneous. 4 empirical correlation result different of homogeneous blending time was caused by developed empirical correlation were based on different technique and monitoring method. Thank you from